The logarithmic function is the inverse of the exponential function. As you can see, a to the power of x equal b can also be written as logarithm of base a of b is equal to x. And now if we go a to the power of x equals b is this one here. The logarithmic function, this green one, y is equal to log of x, and the exponential, the logarithm without a base is a base 10, that means log base 10 of x, and the exponential with a base of 10 is going to be y equals 10 to the power of x. Now if we take logarithm base 10 of 10 to the power of x, these two functions cancel each other out and we'll have this time y equal x, which is actually this line here. The red line is also the axis of symmetry between the two functions, the logarithmic function and the exponential function. We'll now continue with a real-life example, but before that we'll need to have a look at the properties of logarithms. We have b here, so every logarithm we are talking in property number 1, number 2 and number 3 is log base b. So the logarithm of a product is equal to the sum of the logarithms of the two members of that multiplication. So log base b of n times n is going to be equal to log of m plus log of n. Likewise, the division of two factors m over n is going to be the difference of log of m minus log of n. Now imagine that instead of m times n we would have m times n. That would be m times m is equal to m squared. But we know that log of m times m is equal to log of m plus log of m, which is equal to 2 log m. As you can see, these two here has gone in front here. So likewise we can say for any exponent r of m, log of m to the power of r is equal to r log of m. The exponent of m moves in front of the log and becomes a product of r times log of m. And now to change the base of a logarithm, we'll take logarithm of m in a new base a over logarithm in the new base a of the previous base. So log base b of m is going to be log base a of m over log base a of b. And now the real life example. A company owns a $28,000 forklift They are looking at the depreciation rate of 13% per annum. And what we want to find out in the first instance is what is the forklift going to be worth after 5 years. We know that the initial value is 28,000. We want to find the value after n years. $28,000 times 1 minus the rate of depreciation 13 over 100, that's 13%, to the power of the number of years, 5. That is 28,000 times 1 minus 13 over 100 is 0.87 to the power of 5. And that gives us a result of $13,955.80 for the forklift after 5 years. The next question is, when it is worth under 3,000, the forklift is replaced. Form an equation and solve it to find out how long it takes in years before the forklift is worth 3,000. This time around we have 3,000 is Vn. A is still 28,000. The rate of depreciation remains 13%. And we want to find n, which is the number of years it takes for the forklift to depreciate from $28,000 to $3,000. So Vn 3,000 is equal to A 28,000 times 0.87, which is 1 minus 13 over 100, 0.87 to the power of n. And now we rearrange this. We move the 28,000 to this other side, or in other words, we divide both sides of this equation by 28,000 and then simplify by 1,000, get rid of these 3 zeros, and we'll have 0.87 is going to be equal to 3,000 divided by 28,000, which is actually 3 over 28. Now we can take the log of each side, because if these two sides of the equation are equal, the logarithm of these two factors should also be equal. And we have log of 0.87 to the power of n is equal to log of 3 over 28. But as we know, this exponent, we can take it to the front of the logarithm. And log of 0.87 to the power of n becomes n log of 0.87, and that is equal to log of 3 over 28. Now rearranging all this, we'll have n equal to log of 3 over 28 over log of 0.87. So n times this log is equal to this log, therefore n is equal this log divided by this log, and the result is 7.04 years, 7 years more or less, for the forklift to depreciate from 28,000 to 3,000 at a rate of 13%. And the last question is, an electric forklift takes 20 years to depreciate from 28,000 to 3,000. What is the rate to 1 dp of depreciation used for the electric forklift? So now we've got the initial value, which is 28,000. We've got the residual value, which is 3,000. We've got the number of years it takes for the forklift to depreciate from 28,000 to 3,000, which is 20 years, so n equals 20 years. The only remaining unknown is the rate of depreciation r. And now, the residual value is 3,000, the initial value is 28,000, rate of depreciation is r because we don't know it. and the time it takes for the forklift to depreciate from 28,000 to 3,000 is 20 years. And simplifying by 1000, we've got 3 equals 28, brackets 1 minus the same thing. I rearranged this expression here, so divided by 28 both sides, and I have 3 over 28 equals to 1 minus r over 100 to the power of 20. As before, if these two are equal, therefore their logarithms should be equal. So we can say log of 3 over 28 is equal to log of 1 minus r over 100 to the power of 20. And now, because this side here is actually 20 log of 1 minus r over 100, and we can rearrange all that. We can have, if 20 times this log is equal to this, then log of 1 minus r over 100 is going to be equal to log of 3 over 28 divided by 20. So we actually divide by 20 both sides of these expressions. And now we have log of 1 minus r over 100 is equal to log of 3 over 28 over 20. Now we know that this logarithm actually have a base 10. So we can say that 10, so imagine we had here 10, which we don't actually write. So that is 10 to the power of, we write this as an exponential, that this logarithmic expression, we will write it as an exponential, and we have 10 to the power of this here is equal to this bit here. So 10 to the power of this is going to be equal to the brackets, which is 1 minus r over 100. Again, we're going from a logarithmic expression back to an exponential expression, and we use the base of the logarithm base 10 to the power of its result to equal the brackets. Now r over 100 is equal to 1 minus log of 3 over 28, everything over 20, and now we multiply this by 100, and that's the final expression which you can work on your calculator. Remember, the logarithm, the decimal logarithm of any number is actually a number, and you can start working on your calculator over here, and you'll get logarithm of 3 over 28, which is going to be a number, and that you will divide by 20, and then say 10 to the power of the answer, which is this, and you'll get another answer, which is 10 to the power of, you'll have a result for this, and you'll say 1 minus the new answer, and all that answer you'll multiply by 100, and what you'll get is 10.567%. The rate of depreciation over 20 years is 10.6, because we'll need to, as we have been asked, we'll need to round that to 1 dp. So the rate of depreciation is 10.6%. It means that at the rate of 10.6%, our forklift will depreciate from 28,000 to 3,000 in 20 years.